All right, so today we are looking at geometric sequences. All right, so we spent the past couple of days looking at arithmetic sequences. The thing you have to remember, an arithmetic sequence is when the numbers are being added or subtracted by the same number. So they're either all growing by the same or they're all subtracting by the same. All right, now geometric is a very similar type thing. However, it's not going to be adding and subtracting. All right. So the first question is, how do we determine if if a sequence is geometric? You check by seeing if the pattern is completed by multiplication or division. Okay, so to determine if a sequence is geometric, you have to see if the pattern is completed by multiplication or division. Okay, so what that means, in other words, as you look at the sequence, the numbers are going to get bigger a whole lot faster. In arithmetic, if it's plus 2, well, each time it's just plus 2. So if you started at 2, it would be 2, then 4, then 6, then 8, then 10, then 12, right? Because that's arithmetic, you're just adding 2. Well, if it's geometric in your what you call your R value, your common ratio, if it is 2, well, you multiply each number. So you would do 2 times 2, which is 4. But then you would go 4 times 2, which is 8. Then you go 8 times 2, which is 16. So that thing grows a whole lot faster. It's really an example of an exponential, okay, which is a word that you're going to get to know later. All right, so let's go ahead and hop down here and look at this next thing. So just like arithmetic had a formula, geometric also has a formula. The formula for geometric is a sub n equals. Now, this time it is going to be a1 times the common ratio that we call r, and r is raised to the n minus 1 power. Okay? So what that means here is r is a number, a1 is a number, but n minus 1 is an exponent. So it will eventually be a number, but that is up in the exponent. So n minus 1 is not getting multiplied by something. It is being what we call raised to a power. It is an exponent. Okay? How do you feel on that? You okay? Now, here's the beauty of geometric. You remember when they asked us on arithmetic for the explicit formula? We had to plug in a sub 1 and the d value. Then we had to reduce it. With geometric, once you plug them in, you're done. You don't have to reduce anything. So these problems will be a little bit quicker at times. All right? So let's work through some problems like we're going to see on our homework, and make sure that we are good to go. So the first thing is, state if each sequence is geometric. What it is saying, is there a common ratio? Okay, so here is how you find the common ratio. You find the common ratio by taking the second term and dividing it by the first. So when we looked for that in the arithmetic ones, remember we did the second minus the first? Now we're going the second divided by the first. So as you look here to check and see, all right, to try and find this common ratio, you need to take your second term and divide it by the first term. So here we would say r would be 24 divided by 4. And if you don't have a calculator, I highly suggest you get one because you're going to need it for these. But 24 divided by 4 is 6. Well, that should hold true for every single one of these, right? So then we've got to check the next one. Well, what is 144 divided by 24? Does anybody know? 6. And then you want to check your last one. 864 divided by 144 also equals 6. So, since they all equal 6, is this geometric? Your answer would be yes, because the ratio is the same. All right, now, let's look at number 4. Let's see if that one holds for that pattern. Okay, well, remember, I've got to take the second, divide it by the first. So here, 4 divided by 2 is 2. Then you got to check the next one. Well, 12 divided by 4 equals what? 3. Are those the same? No. Since the ratio is not the same, it would not be geometric. Okay. All right, let's come to the next set of problems. The next set of problems simply say, hey, find the common ratio. So what you want to do is you want to ask yourself, what number am I multiplying by each time? That's what you want to ask. Sometimes it's hard to see. What I always do, because I know it's going to work, is I just need to take the second term and divide it by the first. So as I look here, I take my second term divided by the first. So r would equal -6 divided by -2. Well, 2 negatives would make a positive. 6 divided by 2 is 3. So guess what your common ratio is? 3. Here you don't have to check it because they tell you, hey, it is 1, just find the common ratio. All right, let's look at number 6. Number 6 is the same type of thing. You need to take your second term, divide it by the first. So here r equals -18 divided by -3. Again, 2 negatives will make a 18 divided by 3 is, so r equals 6. Any questions there? Okay. All right. Let's look at 7 and 8. Again, they're asking you to find the common ratio given the geometric sequence. Well, here's all I'm going to write down on here. Remember, the formula was a sub n equals a1 times r to the n minus 1. There's nothing you can do to reduce that because of the exponent. So guess what? Each time that you're asked to find your r, it is simply the number that is raised to the n minus 1. So what is the r value in number 7? 4. Y'all are really going to struggle when you have to do this on your own because you refuse to participate. On number 8, what is the r value? What is your common ratio? 2. It is that simple. Your r value is always what gets it for you. Okay? All right, let's continue on here by looking at these. All right? So, 9 and 10, it says, given the first term in the common ratio, find the explicit formula. Well, we're getting used to it still, so I'm going to write it for you again. The explicit formula for the geometric sequence. A sub n is equal to a1 times r to the n minus 1. Now, I'm going to bring something up, and it hasn't happened yet, but it's going to eventually happen. What am I doing every time I write r? Putting it in parentheses. Here's why. Eventually, you're going to get a ratio that is negative. You have to make sure, because you're going to use your calculators to solve these, that you put parentheses around your negative numbers. If you don't, it alters your answer. You hear me? All right. So, it is as simple as this when you come down here. If they're asking you for the formula, is you just have to plug and play. So on this first one, they give us a sub 1 is negative 1, and they give you r is 2. Well, all you've got to do is take that formula and plug them in. A sub 1 is negative 1 times r, which is positive 2, to the n minus 1. Now, this is a great answer. And if it's a free response question, that's all you have to do. However, if it were multiple choice, you would not see it written like this. Do we typically write negative ones when we're multiplying? No, we just put a negative sign out front. So you could also see it written as a sub 1 equals negative, parentheses 2, to the n minus 1. That just means that once you get your answer, you just got to multiply it by a negative 1. Okay? Number 10 is very similar. It's a little bit easier because there's no negatives, but they give you your A1 and your R. So you've just got to plug it in. A sub n would equal, well, A1 is 3 times your R value, which is 5, to the n minus 1 power. Questions? All right. Now, 11 and 12 add a little bit to it, okay? Because they're still asking you for the explicit formula, but you don't have all the stuff. What are the two things you need? You need your a sub 1 value, your first term, and then you need your common ratio, which is r. Now, you can find both of these pretty easily, right? Our first term is simply what is listed out in front. So what is A1 in number 11? 3. Your R value, how do you find it? Yeah, you take the second term, divide it by the first. 9 divided by 3 is 3. So your R value is also 3. Now, they don't ask us to check it here, so we assume that they are geometric sequences, right? Unless they said, hey, is it? Then you can assume that it is one. So that means now we've just got to write the formula. Well, a sub n would be 3 times your common ratio is 3 to the n minus 1 power. Nice, short, and sweet there. Okay? Let's look at number 12. Number 12 is the same directions. Well, that means we need our first term and our common ratio. Okay? Well, our first term is given to us. It is negative 2. To find our R value, we just take the second term, divide it by the first. Negative 12 divided by negative 2. 2 negatives will make 12 divided by 2 is 6. So your common ratio is 6. So a sub n would be negative 2 times 6n for your common ratio to the n minus 1. How are y'all feeling? It's pretty similar, right? The foundation's there, it's just a little bit different. Okay, now, this is the one why I said you would definitely want some kind of calculator. Here they're asking you to evaluate it. So it says, given the explicit formula, find the term in the problem. And the directions are really simple. You just plug in the number for n and then solve it. Here's the issue. It's not just doing algebra now. It's not. because you've got exponents and you're going to have to move some stuff. So I highly suggest that you use a calculator to help you out. So as you look at this, I see that they tell us that we are looking for the 11th term because they're asking for A11. So that means that we're going to come down here and solve this, but anytime we see an N, what do we want to plug in? Anytime we see an N, what do we want to plug in? An 11, thank you. So that means now up top you have 11 minus 1. Well, here is the process for solving this. You first start by doing the math in the exponent. So that means I will leave my parentheses -2, but 11 minus 1 is 10. Now, I'm going to need your help right here because I'm going to show you why parentheses are so important. Okay? There are two different ways you can put this in your calculator. Some of you are going to write this, -2 to the 10 power, whether it's a caret to the 10, whatever it's got to be. Okay? Now, I want y'all to do that math for me. So whoever has their calculator, type it in just like that. -2, I don't want you to use parentheses at all, to the 10th power. Okay? If you do it that way, what happens, okay, are you ready? Is you end up getting -1024. Okay? This answer is wrong. Okay? Here is why it is wrong. Your calculator sees -2 or negative times 2 to the 10th power. Your calculator just does 2 to the 10th power and then multiplies it by this -1 out in front. That is wrong here. What should be raised to the 10th power? -2, not just 2. So if you take your calculator and go parentheses -2 to the 10th power, guess what you get out? Positive 1024. That is the right answer. If you do not enter this correctly into your calculator, it will mess your answers up. This is doing 2 to the 10th times -1. This is doing -2 to the 10th power. They get you different answers. That's why it's so important that you input it correctly. Do you hear what I am saying to you? All right. Good. Okay, now, 14 is a similar type problem. It's a little bit easier because there's no negatives, but they're asking you for a to the 12th power. So that means you need to find a to the 12th. Well, that means you work the problem exactly as is, but once you get to the end, you're going to plug in a 12. Okay? Now, notice some of these worksheets and notes that we create, they don't put parentheses around your n. They'll only do it when it's negative. I just get in the habit of trying to do it all the time. Okay? So, as you look at this, you want to simplify it. Well, can you do anything to the 3 right now? No, save it for the end. We want to reduce that radical, or excuse me, that exponent. What is 12 minus 1? 11. So now look what we have. We have 3 times 2 to the 11th power. Well, before you even think about multiplying by 3, why don't we figure out what 2 to the 11 is? So I take my calculator and I go in there 2 to the 11th power. And if you do that, you get out 2,048. Now we have a problem we can solve because we have 3 times 2,048. So again, I just go to my calculator and multiply it by 3. And I figure out that a to the 12th is equal to 6,144. And that is my answer. Why is the 12 where? Why is it on the bottom right? Why is it up top? Because in our equation given here for geometric, the n minus 1 is in the exponent. So to figure out geometric equations, because they grow so quickly, it's a form of an exponential equation. And you don't know that yet. You're going to learn about an exponential down the road. But exponential graphs do this. They're here, and they skyrocket up. Okay? Or they could skyrocket down. But they grow so fast. Well, when you put something in the exponent, it causes numbers to grow fast. So that is the formula that we have to use to be able to solve it. That's why it's in the top and not in the bottom. All right. We got 2 more problems to look at here. Okay? Now, these problems put it all together. They actually ask you to do everything that we have done on the notes to get here. So they give you some sequences. They ask you to name the term in there. Now, I'll be honest. You don't have to find the explicit formula if you don't want to. You don't. You could just say, okay, let me find the common ratio and I'll just multiply it by each of these until I get there. Now, do you really want to do that to find the 11th term in the sequence? No. That's why it's a lot easier to find the exponential, what's the word I'm looking for? The equation, and plug it in. So, I always start here by saying, okay, well, I need to find my A1 and my common ratio so that I can plug it in. Well, what is A1 in number 15? Perfect. It's 4. Thank y'all. Okay. Then I've got to find my ratio. Okay. Well, I've got to take the second term divided by the fourth, or by the first. Negative 8 divided by 4 becomes negative 2. So now that I've done that, I can find what my formula is. A sub n is equal to 4 times parentheses negative 2 to the n minus 1 power. Now that I have done this, I've got to finish this problem. They asked me to find the 11th term. So that means I need to find a to the 11th instead of a to the n. So that means I would get 4 times parentheses negative 2 to the 11 minus 1. There you get 4 times negative 2. 11 minus 1 is 10. And then it's just solving it like we did before. Can't do anything with the 4 yet. I use my parentheses in my calculator of negative 2 to the 10th power. So I got out 1,024, and it was positive. And then I take that times 4 and figure out that a to the 11th is really 4,096. So you can see that this process is literally just following everything that we have done on the notes. Okay, now, I'm going to give you a stern little talking to for 30 seconds. I don't see many of you actually using a calculator. So this is going to be harder when you get to do it by yourself, because you have not gone through the process with me and asked, hey, I had trouble here, I didn't have trouble here, I see what you did, Coach Dasher. This isn't a hang out and I'll figure it out type deal. So you're going to struggle a little bit with this. That's why we're spending 2 days on it. But if you don't try it, the struggle will continue to be real, quote unquote. All right, so looking at 16 real quick. Okay, A sub 1 and R are what we need because they're asking us to find the 10th term. Well, A sub 1 is 1. Hey, guess what? I don't even really need to do the equation to figure out what my R is. When my first term is 1, well, whatever my second term is, that's what I multiplied by. So I multiplied here by 3. So now that I have that stuff, okay, you have a sub n is equal to 1 times parentheses 3 to the n minus 1. Now, I'm going to show you something here. What is 1 times anything? Itself, whatever you multiplied by, right? So really, I can skip down and just call this, hey, a sub n is equal to 3 to the n minus 1 power. Then I can take this and solve my final term. So I want to find a to the 10th power. So that means I would get 3 to the 10 minus 1. Well, if I reduce that, I end up getting 3 to the 9th power. And then if I plug that into my calculator, I end up figuring out that the 10th term is 19,683. So notice with geometric sequences, you tend to think that your numbers will be bigger. Okay? All right, what I'm going to do now is pass out to you your practice sheet and give you some time to work. Ready, set, go.